My name is Gianluca Marlente. I'm a principal engineer at Cisco Systems, and I've been working on Kubernetes for the last 5 years. I started at Tegera, which is the company behind Project Calico, and I went to Cisco and kept working there on Kubernetes. And on the side, I've been maintaining this open source project, which is called Project Sveltos. I've been working on this for 18 months now. As you know, when you create a Kubernetes cluster, you need to deploy add-ons and application to make it a production cluster. There are tools that allow you to programmatically create, upgrade, or delete a cluster. Cluster API is becoming probably the standard there. And Sveltos is a tool that can be used on top of it to programmatically manage add-ons and application in a fleet of clusters. So Sveltos runs in a management cluster, and cluster profile is the main CRD which is introduced by Sveltos to be instructed on what to do. And from there, Sveltos can manage a fleet of Kubernetes clusters. Now, those clusters can be cluster API powered cluster. Sveltos has built-in support for cluster API, meaning that if you create a cluster API powered cluster, there is nothing else that you have to do. Sveltos automatically detects this cluster and is able to manage it. But if you have any other type of cluster, you can simply register with Sveltos, and then Sveltos can manage from that point on. In the demo that I have prepared, I create like a GK cluster, and we'll have Sveltos manage like this GK cluster. The only things that Sveltos requires is a network connectivity from the management cluster and those managed clusters. How does Sveltos work? Cluster profile is the main CRD, and it has in its spec section a cluster selector, which is just a Kubernetes label selector. It's selecting all the clusters where the add-ons needs to be deployed. In this case, it's selecting all the clusters which have label, environment, functional verification, FE. And then it has the section, Helm charts, customization refs, and policy refs. The Helm chart section, it's a section where you can have one or more Helm charts that needs to be deployed. In this case, we are asking Sveltos to simply deploy Kyverno version 2.6.0. The customization ref section is a section where you can tell Sveltos where to get the customized file. In this case, we are telling Sveltos to get this customization file from a Git repo. Git repo is synced with Flux, and then Sveltos will use the content of this Git repo to run the customize SDK, get the resources that needs to be deployed, and deploy the resources in all the clusters matching the cluster selector. And finally, there is a policy ref section. Sometimes it's convenient to put your configuration, your YAML and JSON in a config map data section or a secret data section. Referencing the config map or secrets from here will have Sveltos get the content of this config map and secrets and deploy the content in all the clusters matching the cluster selector. This is an example of a config map where in the data section I have stored a gateway class and a gateway. So if there were a cluster profile referencing this config map, Sveltos will take the content of this config map and deploy it. So it will deploy the gateway class and the gateway in all the clusters matching the cluster selector defined in the cluster profile. Here I have a slide where I'm summarizing with some animation how Sveltos works. So we start by posting a cluster profile, and we're telling Sveltos find all the clusters which match the cluster selector environment prod, and deploy Kyverno version 2.5.0 in all such clusters. So if we add the label environment production in the first workload cluster, Sveltos is going to detect that this cluster is a match. And because this cluster is a match, it's going to take all the add-ons and applications listed in this cluster profile, in this case just Kyverno Helm chart, and it's going to deploy it. As simple as that. So if we add the environment production label on the second managed cluster, same thing's going to happen. Automatically, Sveltos will detect that this cluster starts being a match, and it will deploy Kyverno on this cluster as well. The same way, Sveltos can be used to deploy add-ons and application in managed clusters. Sveltos can withdraw those add-ons and application. For instance, If we remove the label environment production from the second main workload cluster, this cluster stops being a match, and so Sveltos is gonna withdraw Kyverno. This behavior though is configurable. This is the default behavior, but Sveltos can be configured to leave the add-ons and applications that he has deployed on a cluster when the cluster stops being a match. And you will use this use case if you are creating a cluster for a tenant, for instance, and you want to pre-populate these clusters with a set of add-ons and applications, but then you let the tenant decide whether he still wants this information or not, those add-ons and applications or not. Now, one of the main reasons why I developed Sveltos was that I wanted like something which was dynamic in nature. Dynamic in nature means that I want all the add-ons and applications, Helm charts or content, YAML or JSON passed like in the config map or secrets to be expressed as a template. And Sveltos, it's able of instantiate those templates at deployment time using information which are coming from the management cluster. Here is an example. I want to deploy Calico in all the classes which are matching the label environment production. Now, Calico needs the port header blocks, so I can achieve that. I add a value section to this Helm chart, and this value section, it's expressed as a template. I know that if I'm about to deploy Calico in a cluster which is powered by Cluster API, I know that in the management cluster, there is a Cluster API cluster instance representing the cluster, and in its spec cluster network port header, it contains the port header blocks. So what I'm telling Sveltos is, when you're about to deploy these Helm charts, take this resource, which is present in the management cluster, take this information from this resource present in the management cluster, instantiate this value section, and only then deploy the Helm chart. By default, Sveltos can fetch certain resources in the management cluster. Cluster API resources like the cluster instance, the infrastructure provider instance, the Kubernetes control plane, or the Sveltos cluster instance. But essentially, Sveltos can be instructed to fetch any information from the management cluster, provided that Sveltos is granted the permission to do so. In this example, I'm asking Sveltos to deploy the content of this config map, which is in the default namespace called info. But before Sveltos does that, I want Sveltos to fetch this secret, which is present in the management cluster in the default namespace, and it's called autoscaler. And I want to identify these resources autoscaler secret. So if we look at the content of the config map is a template. There is this annotation which indicates Sveltos that the content is a template. And this template is actually using the identifier autoscaler secret, and then it's using the data token and CA/CRT. So it's using like information which is present in the secrets present in the management cluster. So what Sveltos is going to do, it's going to fetch the secrets present in the management cluster. It's going to instantiate this template and then deploy the instantiated template in the managed cluster, matching the cluster profile. Because of this dynamic nature, Sveltos being able to fetch resources from the management cluster, Sveltos can also be used to coordinate other open source projects. I want to mention that on top of reading the sources from the management cluster, Sveltos can also create resources in the management cluster. So in this example here, we're using Cluster API, Sveltos, and Crossplane all together. We're using Cluster API to programmatically create a cluster. Once the cluster is created, we are posting a cluster profile, and this cluster profile, it's asking Sveltos to first deploy a crossplane bucket in the management cluster. Now, because we are deploying the crossplane bucket in the management cluster, we are triggering crossplane, and crossplane will go and create a Google storage bucket. And when done, it's going to update the crossplane bucket status. What Sveltos is going to do at this point is going to fetch the crossplane bucket status. The crossplane bucket resources is going to take the status, the information present in the status section, and it's going to use this information to instantiate pod template with the bucket URL. The pod template was also present in the cluster profile. And then it's going to deploy the instantiated pod in the managed cluster. And because now this pod has the information as the bucket URL, pretty much you can upload the file to the bucket, to the Google Storage bucket. So in this case, we're using Sveltos to coordinate crossplay before deploying, and then uses the information that coming from crossplay to instantiate a template and deploy a pod in the managed cluster. Another example would be to use Sveltos piped with external secret operator piped with Sveltos. So external secret operator is an open source project that can fetch secrets from external secrets management system. In this case, we are having the external secret operator fetches secrets from the Google Cloud Secrets Manager, and it's going to bring these secrets into the management cluster. And then we tell Sveltos to take this information, which is coming from the external secret operator in the management cluster, take it to deploy to the managed clusters. So it's going to deploy to the cluster API Power cluster and to the GK clusters. Sveltos also has an ability to detect any configuration drift. So let's take an example to explain what that means. Let's say that we are telling Sveltos to deploy Kyverno in any cluster which is matching the label environment production. Okay, like the typo here. This should be environment production to match this cluster selector. There's a typo in the slide. But essentially, as soon as this cluster matches like this cluster selector, Kyverno gets deployed. And the Sveltos agent gets deployed as well because we have the sync mode to continuous with drift detection. And now, because this other cluster is also matched, Kyverno gets deployed in this other cluster as well. Now, what this Sveltos agent is going to do in this case is going to watch for all the resources that Sveltos has deployed in this cluster, and this Sveltos agent running in this other cluster is going to watch for all the resources that Sveltos has deployed in this other managed cluster. So if someone now comes and issue this command to delete deployment of namespace Kyverno of Kyverno directly to the managed cluster, what is going to happen is that the Kyverno deployment is going to be deleted. Now, the Sveltos agent, which was watching for the sources deployed by Sveltos in this cluster here, is going to detect that this is a potential configuration drift. And so it's going to notify Sveltos running in the management cluster, and the Sveltos reaction will be to reconcile back and put Kyverno back. So if you tell Sveltos that this is how you can make sure that no matter what happens in the managed clusters, the resource, the state of those managed cluster, it's always in sync with the state defined in the management cluster. Sveltos has also another capability to classify clusters based on their runtime state. Let's say that I want to deploy Gatekeeper on any cluster running a Kubernetes version greater or equal than 124, but strictly less than 125. I can introduce a second CRD clock classifier. What this classifier instance is saying is find all the clusters which are running a Kubernetes version greater than or equal to 124, but strictly less than 125. If you find any such cluster, add this label to the cluster gatekeeper v39. And then we pair this classifier instance with the cluster profile instance. It says like if you find any cluster running with matching this cluster selector gatekeeper 39, which is exactly the same labels here, then deploy gatekeeper version 390. So what is going to happen when I do that, when I post this classifier cluster profile pair, that this Sveltos agent is going to detect that both clusters are a match for this cluster profile because they are for this classifier, because they are running Kubernetes version 124.2, which is greater than or equal to 125.0, but strictly less than 125. And because of that, this label gatekeeper 39 is going to be added to both the clusters. Now, because this label has been added to both the clusters, those clusters become a match for this cluster profile. And because they are a match for this cluster profile, all the add-ons listed in this cluster profile will be deployed. So gatekeeper 39 gets deployed in both the clusters. What happens if now I want to upgrade gatekeeper to version 3.10.0 if the cluster gets upgraded to a version which is Kubernetes version which is higher or equal than 125. Well, I can post another combination, another pair of classifier profile. I can have a classifier that says if you find any cluster which is running a version of Kubernetes which is greater than or equal to 125.0, the label that the cluster should have is gatekeeper b310. And then I pair this classifier instance with the cluster profile instance that says if you find any cluster matching the cluster selector gatekeeper 310, then I want gatekeeper 310 to be deployed in such cluster. So let's see what happens if this cluster here gets upgraded. If this cluster gets upgraded from 124.2 to 125.2, this cluster will stop being a match for the old classifier. It will start being a match for this new classifier. Because a match for the new classifier, the label gets updated to gatekeeper v310. And because the label is updated to gatekeeper v310, now this cluster stops being a match for the old cluster profile and starts being a match for the new cluster profile. And so the gatekeeper version gets upgraded to 310.0 by Sveltos automatically. So Sveltos has many other features, but it will take like too long to cover all of them. So done with the slides, but I've prepared the demo here. I do have a management cluster running locally, and in the management cluster I have cluster API deployed and Docker as cluster API infrastructure provider, and I have Sveltos. Currently there is no cluster profile instance deployed in the management cluster yet. And if I use Sveltos Cuddle to display which add-ons and applications are deployed by Sveltos in which clusters, there is none of these deployed yet. Going back to the management cluster, I do have one cluster which is powered by cluster API, and I do have several clusters which are registered to be managed by cluster. In this case, 3 Sevo cluster, cluster 1, cluster 2, cluster 3, each running a different Kubernetes version, 126, 127, 128, and 2 GK clusters. Also those one are registered to be managed by Sveltos. When I look at the labels on those clusters, this is important, all those clusters have the label environment functional verification set. Now, I have prepared like few cluster profile instances that to show Sveltos feature. The first one, it's a cluster profile instance called named Kyverno, and it's asking Sveltos to deploy Kyverno Helm release version 3.0.1 in any cluster matching the cluster selector environment functional verification. So I can go ahead and apply this cluster profile instance in the management cluster. And because every cluster as managed by cluster as the label environment functional verification, what I expect is that Sveltos detects that all those clusters are a match for the cluster profile instance that we just deployed in the management cluster. And so Kyverno gets deployed in all those managed clusters. So we can go and look at the Sveltos Cuddle show add-ons command, and we can see that Sveltos is already deploying Kyverno. It has deployed Kyverno in the cluster API power cluster. It's deployed Kyverno now in the cluster, in the Sevo cluster 1, Sevo cluster 2, Sevo cluster 3, and behind the scenes is also deploying like Kyverno in the 2 GK clusters that we have that should soon come up. Yes, so now Sveltos has deployed Kyverno in every cluster. Using this Sveltos Cuddle show add-ons command, you can see that what is deployed. So in this case, like Kyverno Helm chart version 3.0.1 has been deployed in all those clusters because of this cluster profile Kyverno, and this is the time where pretty much this was deployed. Keep looking at this one. I also prepared another cluster profile instance. This cluster profile instance is called Nginx, and it's asking Sveltos to deploy the Nginx element chart in every cluster matching the label environment functional verification. But the difference is that in this case we're setting the syncs mode to be continuous with drift detection, and I'll explain what this means with an example. So we can start deploying this Nginx cluster profile, and again, if we look at the cluster selector, set to selecting every cluster with environment functional verification, so every clusters that we currently have and are managed by Sveltos. So we can go and see that Sveltos is already deployed Nginx in the Civo cluster 1, Civo cluster 2, Civo cluster 3, in the cluster API power cluster, and in the 2 GKE clusters. Now, I do have the kubeconfig to access any of those managed clusters. If, for instance, we access the Civo cluster 1, and we look at the deployments that are present in this cluster, you can see that Nginx has been deployed in this cluster here. Now, the Nginx cluster profile, it's instructing Sveltos to use the configuration drift detection. What that means is that Sveltos has deployed this agent, drift detection manager, in the managed cluster, and if any resource which is deployed by Sveltos in this cluster because of a cluster profile with sync mode continuous with drift detection, if I issue any command directly in this managed cluster that touches any of those resources, Sveltos will detect and reconcile back. So what we can do, for instance, is delete this deployment. So I'm issuing a delete of the Nginx deployment directly in the managed cluster. So if I look for the deployments, the Nginx deployment now is not present. But if I keep looking, I should see that the Nginx deployment comes back. So, watch for the deployments, and we can see that the Nginx deployment has been deployed back. So what has happened in the background? What has happened is that this component, the drift detection manager, has detected that I issue a command directly in the managed cluster, deleting the resources that Sveltos had deployed there. And as soon as the drift detection manager detects that, it reports back to Sveltos running the management cluster, and Sveltos management cluster now knows that the configuration in this managed cluster, it's not the same as the expected configuration that is defined in the management cluster, and so it reconciles back and put all the resources back. So again, we can look at the Nginx deployment, it's back. Now, we can look at one more thing. I want to show one more thing. We can look at all the clusters that are registered to be managed by Sveltos. And we can see that all the clusters except Civo cluster 1 are running a Kubernetes version which is higher than 127. So Civo cluster 2 is running 127.1, Civo cluster 3 is running 128.2, GK cluster 1 is running 127.3, GK cluster 2 is running 128.3. But Civo cluster 1 is running Kubernetes version 126.4. Now, I have prepared another cluster profile which is saying that in any cluster which has this label, deploy Prometheus, deploy two Helm charts. The Prometheus Helm charts version 23.40 and the Grafana Helm charts version 6.58.9. So I can go ahead and deploy this cluster profile. As of now, if we look again at the labels, none of the clusters have the label deploy Prometheus. So I expect that Sveltos won't deploy Nginx, won't deploy Prometheus or Grafana anywhere. And as a matter of fact, pretty much it's not deploying anywhere. But what I want to tell Sveltos is, if there is any cluster which is, excuse me, if there is any cluster which is running a version which is higher than 127, I want you to add the label deploy Prometheus. So this is the second, this is the classifier instance. And what this classifier instance, it's telling Sveltos it's find any cluster which is running a Kubernetes version which is higher than 127.0, greater than or equal to 127.0, and add those label deploy Prometheus. Now, if this label here, deploy Prometheus, is added to any cluster, the cluster is going to be a match for this cluster profile, because this cluster profile, cluster selector, is deploy Prometheus. And so Prometheus and Grafana are going to be deployed here. So let's go ahead and deploy the classifier instance. Now that we have the classifier instance, we can go again back and look at the Sveltos clusters. And as I mentioned, all the clusters but Sivo cluster 1 are running a version which is greater than or equal to 127.0. So what I expect is that Sveltos is going to add the label deploy Prometheus to any such cluster. So let's run the show labels again. It's not been set yet, let's make sure that we deploy the classifier instance. So the classifier instance has been deployed. So we can start looking at those labels, and we can see that Sveltos has added the label deploy Prometheus to any cluster which is running the Kubernetes version which is greater than or equal to 127.0. Now, because Sveltos has added this label, what I expect is that Prometheus and Grafana are deployed anywhere but on Sivo cluster 1. As a matter of fact, like there is only Nginx and Kyverno deployed on Sivo cluster 1, but Grafana and let's use a command without a watch. Grafana and Prometheus are deployed on the GK cluster 2. Grafana and Prometheus are deployed on the GK cluster 1. Grafana and Prometheus are deployed on the cluster API power clusters and are deployed on the Sivo cluster 3 and are deployed on the Sivo cluster 2, but they're not deployed on the Sivo cluster 1 because again, Sivo cluster 1 is running a version which is 126.4, and so it's not a match for the classifier, and so the label has not been added there. One more thing that I want to show, it's what happens if, so we have like those cluster, we have many cluster profiles. So what happens if I delete, for instance, the Kyverno cluster profile? Well, the default behavior for Sveltos is to remove the Kyverno from any cluster that was a match where Kyverno was deployed. So if we start looking again at show add-ons, we should see that at this point Kyverno gets removed from all the clusters. It's been removed from cluster 1, it's been removed from Sivo cluster 2, it's been removed pretty much essentially from every cluster. Yeah, there is no Kyverno anymore. And the cluster profile at this point is going to be gone because pretty much Kyverno is removed like from every cluster. Yeah, so this is deployed, this is removed. And this is the default behavior, so it's configurable. Sveltos can also be instructed to leave the resources that he has deployed on a cluster when it stops being a match. This concludes the demo. I want to add that if there is any few pointers helpful for the project Sveltos, the GitHub repo, github.com project Sveltos, the documentation is project Sveltos.github.io/Sveltos, and the Slack channel is project Sveltos, and you can find me like on LinkedIn. Happy to connect to anybody who is interested like in DevOps, Kubernetes, and project Sveltos. Thank you so much.